Exercise 3.18, problem 5, solution. Okay. If alpha beta are the roots of the equation 2x square minus 3x minus 5 equal to 0, form a equation whose roots are alpha square and beta square. It is just one more step here. So, since alpha beta are the roots of this equation, you can calculate alpha plus beta, which is minus b by a, and alpha beta is c by a. Now, we are asked to find the equation whose roots are alpha square and beta square. The formula is x square minus sum of the roots plus product of the roots. What's the sum of the roots? Alpha square plus beta square. And product of the roots is alpha square, beta square. Earlier, in all the previous problems, we were asked to find the values of alpha square, beta square, alpha square plus beta square, etc. Right now, they have gone ahead and asking us to use that values also. So you will be able to use it in that equation x square minus sum of the roots into x plus product of the roots. Am I right? So all we need to do is find the value of alpha square plus beta square using the value of alpha beta, and the product of the roots here is alpha square beta square, again using the values of alpha beta which was calculated from this equation. Right? So this equation forms the base from which you get alpha plus beta and alpha beta. Using those values, you should be able to calculate the sum of the roots, which is alpha square plus beta square, and product of the roots, which is alpha square beta square. Once those two values are known, you can easily form the equation using x square minus sum of the roots into x plus product of the roots into equal to 0. Right? Let's try it. So, in the given equation, a equal to 2, b is minus 3, and c is 5. Okay. Right. Sum of the roots is alpha plus beta, that is minus b by a, that is minus of minus 3 divided by 2, that is 3 by 2. Product of the roots is 5 by constant divided by a, c by a, that is 5 by 2. Now, we are asked, or we are given that the roots of the new equation or the required equation is alpha square plus beta square. What is the required equation? Let's find the sum of the roots. The sum of the roots will be alpha square plus beta square. And what is alpha square plus beta square? That is alpha plus beta the whole square minus 2 alpha beta. As in the previous cases, what all we are asked to do, we have to express them in terms of alpha beta and alpha beta. This is the key for all these problems. Because only these two values we know, so all these things needs to be expressed in terms of the known values of alpha plus beta and alpha beta. That's all we know here. We know alpha plus beta is 3 by 2 and alpha beta is 5 by 2. So using that identity, a square plus b square is a plus b, the whole square is 2a minus 2ab, we are getting this formula. Right? Now, product of the roots is alpha square beta square, which is alpha beta the whole square. Again, this is known. So which means the sum of the roots and the product of the roots can be calculated. And what is the equation? Equation is, anyway, let's complete this. Sum of the roots is alpha plus beta the whole square minus 2 alpha beta, right? So substituting the known values, you get 3 by 2 the whole square minus 2 into minus 5 by 2. Sorry, it's not minus, it's plus. It's a mistake. Okay. So this is 9 by 4. And 2 and 2 will get cancelled. Okay. Okay, there is a small mistake here. C is not 5, it is minus 5. So the product of the roots alpha beta is minus c by a, that is minus 5 by 2. It's not plus 5. Similarly, here I had written it correctly. It is minus 5 only. So I have made it plus in the previous single by mistake. So it is minus 5 by 2 only. Okay, so this will become 9 by 4 minus 2 into minus 5 by 2. So minus to minus will become plus, and 2 and 2 will cancel. So we will get 9 by 4 plus 5, which on taking LCM you will get 9 plus 5 4s are 20 by 4, that is 29 by 4. Okay, I made these corrections. C is equal to minus 5 and alpha beta here is also minus 5 by 2. So it will come down as minus 5 by 2 only. Okay, so it's because I missed the negative sign here, whole thing went wrong. Okay. So sum of the roots we have calculated. Next, product of the roots is minus 5 by 2 the whole square, but because it's a square it does not affect us, it's becoming 25 by 4. right? Now, what's the required equation? The required equation is x square minus sum of the roots into x plus product of the roots equal to 0. So we need to calculate this. Sorry, we have this value and we have this value, which means you substitute these two and you'll be able to get the quadratic equation. So now the required equation will be x square and the sum of the roots we calculated it as 29 by 4. So it is minus 29 by 4x plus the product of the roots is 25 by 4. So this is the quadratic equation, and what you do is we multiply both sides by 4. You will get 4x square minus 29x plus 25 equal to 0 is the required equation. Okay, so all we are doing is that from the given equation you are calculating alpha plus beta and alpha beta, and after that you are asked to find the roots of alpha square, the roots of an equation find an equation whose roots are alpha square and beta square. So the equation is always x squared minus sum of the roots plus product of the roots. So in this case you will have to find alpha square plus beta square, which is the sum of the roots, and the product of the roots is alpha square beta square. So these two expressions, try to write it in terms of our known values of alpha plus beta and alpha beta, and using the values of alpha plus beta and alpha beta, calculate them. That is alpha square plus beta square and alpha square beta square. So once you know those values, substitute in the equation x square minus sum of the roots into x plus product of the roots equal to 0 to get the required equation. Okay, so that's all in this problem. I hope I made it clear. If not, please go through one more time. It will become clear. Thanks for watching this video.